Hello and welcome to Earthquake Tip number 28. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 28 will explain you what is confined masonry construction. Most of the construction in our country is unreinforced masonry, and it has been learned during past earthquakes that these buildings perform poorly, causing loss of lives and property. Therefore, a new construction system that is confined masonry is evolved. Let's first understand the basics of confined masonry through this figure number 1. Confined masonry typically consists of, as you can see in this figure 1A, traditional strip foundation in masonry, as you often find in conventional masonry construction. Then you have RCC plinth beam. Then you have masonry walls, that is brick or concrete walls built on top of plinth beam. Then you have small RCC, vertical and horizontal confining elements built around these masonry walls. And then you have RCC floor and roof slabs built monolithically with these confining elements. These vertical and horizontal confining elements are called tie beams and tie columns. Confined masonry construction has a mandatory plinth beam on top of plinth masonry. Figure 1B shows a four-story house in South America using confined masonry construction. It's a good construction technology for low and medium rise houses in seismically vulnerable areas. Now let's understand construction sequence of confined masonry. As you can see in this figure 2, construction of confined masonry building with RCC confining elements in walls, making masonry walls in small panels, each of which is confined by all four sides by vertical and horizontal RCC elements. Concrete is poured in these vertical and horizontal confining elements after walls are built. These confining elements hold the masonry in place and improve integrity of house during seismic shaking. Let me give you example of 2010 Chile earthquake, which was of magnitude 8.8, and during this earthquake, confined masonry houses performed very well, while many unreinforced masonry and even RCC buildings suffered damage. The concept of confined masonry wall construction, confined with wooden elements, has been in use for centuries in many earthquake-prone regions along the alpine Himalayan belt. For example, in Kashmir Valley of India, Dhajji Diwali, a local vernacular construction, consists of large masonry walls broken into smaller panels with wood vertical, horizontals, and diagonals. These houses showed excellent performance in many past earthquakes and helped avoid loss of life. These houses have simple architectural design, good quality materials, and good quality of construction. Now let's understand how confined masonry is different from movement resisting frames with unreinforced masonry infills. Confined masonry houses are different substantially from RCC movement resisting frames with masonry infills. Even though both technologies use the same constituent structural materials, that is, concrete and masonry and have similar appearance when the buildings are constructed, but they are different. Let me elaborate these differences through these three things. First is different behavior. Confined masonry houses are load-bearing structures because here masonry walls carry gravity and earthquake-induced lateral forces. This is similar to unreinforced masonry construction being used in India for many centuries. These unreinforced masonry houses perform well under gravity loads but experience significant damage during earthquake shaking because masonry cannot take any tension that develops during earthquake shaking, whereas RCC moment resisting frames houses are classified under moment resisting frame system. RCC frames are infilled with unreinforced masonry wall in some countries like India, whereas with engineered infills in other countries such as New Zealand. Second is different construction sequence. Let's first understand this different construction sequence through this figure 3. Construction sequence is distinctly different for two construction types, that is confined masonry house and moment resisting frames with masonry infills. As you can see in this figure 3a, in confined masonry construction, masonry walls are built simultaneously with reinforcement in vertical and horizontal RCC confining elements, and then concrete is poured in these elements at the end. Whereas you can see in figure 3b, in RCC frame construction, first the RCC frame is built, that is footing, columns, beams and slabs, and then the masonry walls, the panels are infilled in open base between RCC columns and beam. The third difference is design complexity. In confined masonry houses, RCC confining elements act primarily in compression and tension, and connections between these elements are pinned. That means there is no flexure. Hence, RCC tie beams and tie columns are smaller in size and require lesser reinforcement compared to RCC frame members. Whereas in RCC moment resisting frame houses, RCC members largely undergo tension and shearing, and therefore they need to be larger in terms of size and amount of reinforcement. For design of low-rise confined masonry houses, prescriptive approach may be adequate, but for RCC frame construction, engineering design approach is required. Therefore, we can say that design efforts may be considerably smaller for confined masonry houses than the RCC framed houses. Now, let's look at this figure 4. RCC confining elements enhance stability and strength of brittle masonry walls, that is, interaction between masonry walls, structural integrity and containment of earthquake damage within masonry walls. These advantages lead to ductile earthquake performance of confined masonry houses over those of alternative concrete and masonry building technologies with relatively lower level of technical efforts. Further, confined masonry houses are more economical for the same functional use. For these reasons, confined masonry construction is most suitable for low and medium rise housing in earthquake prone areas than RCC frame construction. Design codes for masonry, confined masonry construction have been in place for more than 50 years in several countries, especially in South American countries like Chile, Argentina, Mexico. But confined masonry construction has not been practiced in many countries, including India. But now, codal provisions for confined masonry construction are being developed to promote this construction technology. Most design codes lay down prescriptive guidelines for architectural, structural, and constructional aspects of low-rise confined masonry buildings and provide requirements for engineering design of tall confined masonry buildings. These design codes are based on experimental verification through testing, analytical research, as well as earthquake performance during past earthquakes. This is all about earthquake tip number 28. You can download this earthquake tip from www.bmtpc.org. The next earthquake tip, that is tip number 29, will be on what are the essential features of confined masonry houses. Thank you very much.